Hello everyone, I am Mrs. Bhoite Gauri, Assistant Professor in First Year Department, VP KBIT Baramati. For First Year Department in Subject Engineering Mathematics 1, the Unit 5th is Matrices. So we are using so many times matrices to represent the data. So we see in this lecture basics of matrices. So what is matrices first? So a matrix is an arrangement of mn numbers in m rows and n columns. An arrangement of mn numbers in m rows and n columns in a square or rectangular array is matrix. See the example. The arrangement of two numbers in one row or an arrangement of these four numbers in two rows and two columns. In general, the matrix is given as denoted as capital letters capital A, B, C, and the elements is denoted as small a, I, J. So if matrix A has m rows and n columns, then its elements are denoted as A11, A12, A1j, A1n, A21, A22, A2n, and the last row is AM1, AM2, AMJ, and AMN. So in general, A is Aij element, where this I goes from 1 to m and this j goes from 1 to n. Now we see first order of matrix. If matrix has m rows and n columns, then order of that matrix is m cross n and we read is m by n. Repeat. Order of matrix is if the matrix has m rows and n columns, then order of that matrix is m cross n. So let us see example. This A matrix has 3 rows and 3 columns. So order of matrix A is 3 cross 3. Another example B. It has 2 rows and 1, 2, 3 and 4 columns. So order of matrix B is 2 cross 4. Now depend upon order, we divide the matrix into some types. So first we see types of matrices. So first is column matrix. So a matrix having only one column and any number of rows is known as column matrix. So this example, matrix having only single row. Row matrix or row vector. A matrix having only single row and any number of columns is known as row matrix. The third type, rectangular matrix. It contains more than one element and number of rows need not be equal to number of columns. So next type, null matrix or zero matrix. If all elements in the matrix are 0, then that matrix is known as zero matrix. That is Aij is equal to 0 for all I and j. So each element is 0. Sometimes it is denoted as O. Now square matrix. A matrix is said to be square matrix if the number of rows is equal to number of columns in that matrix if number of rows is equal to number of columns. Okay. So see this matrix A has 2 rows and 2 columns. So it is a square matrix. So sometimes it is denoted by that common number n. So A is a matrix of order 2. We can say here matrix B has 3 rows and 3 columns. So B is a matrix of order 3. So this is very important matrix, square matrix. Now we define diagonal elements of square matrix. So the diagonal element of a square matrix are the elements of position Aij for which I is equal to j. So first row first column element, second row second column. So A11, A22, these are the diagonal elements, or here 1, 9, 8, these are the diagonal elements of the matrix. Okay. Now next, triangular matrix. So a matrix which is square matrix and whose elements below or above are 0. All the elements above the diagonal or below the diagonal are 0, then it is a triangular matrix. So see the example. Here the elements above diagonal are 0. In this third example, the elements below diagonal are 0. So these all are the triangular matrix. We can specify this triangular matrix into two types, upper triangular and lower triangular. So what is upper triangular matrix? So a square matrix in which all the elements below the main diagonal elements are 0, then it is upper triangular matrix. That is Aij is equal to 0 for all I greater than 0. So it is the elements below the main diagonal are 0. So these are the examples where the elements below the main diagonals are 0. Now next type, lower triangular matrix. A square matrix in which all the elements above the main diagonal are 0. What is lower triangular? A square matrix in which all the elements above the main diagonals are 0. So here the elements above main diagonal are 0, that is Aij is equal to 0 for all I less than j. It is lower triangular. Now next type is diagonal matrix. So what is diagonal matrix? A square matrix where all the non-diagonal elements are 0. A square matrix in which all non-diagonal elements or off-diagonal elements are 0. So where Aij is equal to 0 for all I is not equal to j. Here diagonal element might be 0 or non-zero, but off-diagonal elements are 0. So diagonal element is upper triangular as well as lower triangular matrix. Only diagonal elements are might be 0, might be non-zero, but non-diagonal elements are 0, then it is diagonal matrix. Next type, scalar matrix. Now a matrix which is diagonal matrix in which all main diagonal elements are same. So what is a scalar matrix? Diagonal matrix, that is off diagonal elements are 0 and plus all the diagonal elements are equal. So here it is a matrix, off diagonal elements are 0 and all the diagonal elements A11, A22, A33 are 1. So therefore it is scalar matrix. Okay. So how we define in general? Aij is equal to 0 for all I is not equal to j, and Aij is some k or a for I is equal to j. It is a scalar matrix. Next is unit matrix or identity matrix. So it is a diagonal matrix with all diagonal elements are 1. It is a diagonal matrix with all diagonal elements are 1. So diagonal matrix means off diagonal elements are 0 and the position of diagonal elements, each entry is 1. So A11, A22, A33, A44, it is 4. So diagonal matrix is generally denoted as IN. I2 means identity matrix of order 2 by 2. I4 means identity matrix of order 4 by 4. Next we see transpose of a matrix. So what is transpose of matrix? A matrix is obtained by interchanging its rows and columns. Transpose of matrix is a matrix obtained by interchanging of rows and columns of given matrix A. So if A is given matrix, its transpose is denoted as A transpose. Okay. So for example, A is given matrix of order 2 by 3. Elements, first row is 2, 4, 7. Second row is 4, 5, 3, 1. Then how we obtain A transpose? I convert first row as first column. So for A transpose, my first column is 2, 4, 7. First row I convert into first column. Second row as a second column. 5, 3, 1. So by interchanging first row and first column, we obtain A transpose. Now we see properties of transpose matrix. So if A plus B transpose is same as A transpose plus B transpose. The second property, AB whole transpose is same as B transpose into A transpose. It is also known as reverse law for transpose. Now next, if K is a scalar quantity, then K times A transpose is also same as K into A transpose. And the fourth property, A transpose transpose is equal to A. That is, transpose of transpose matrix is same as A. Now there are two types of matrices based on this transpose of matrix. First is symmetric matrix. Next type. So a square matrix is symmetric if it is equal to its transpose. That is, if A is equal to A transpose, matrix and its transpose both are equal, then matrix is symmetric matrix. So let us see an example. A is a matrix. First row is 2, 3. Second row is 3, 5. If I interchange its rows and columns, first row is same as first column 2, 3. First column is also 3, 2, 3. Second row 3, 5. Second column 3, 5. So if I interchange its rows and columns, I get same matrix. So therefore A is symmetric matrix. In general, this Aij is equal to Aj for non-diagonal elements. Now we see skew symmetric matrix. A matrix is said to be skew symmetric if its transpose is equal to minus times A transpose. A matrix is skew symmetric matrix if A is equal to minus times A transpose, and here Aij is equal to minus times Aj. Now by using this property, the diagonal elements of skew symmetric matrices are 0. The diagonal elements of skew symmetric matrix are 0. Next type, singular matrices. So just I give the definition. A square matrix is said to be singular if determinant of matrix A is 0. So see here the determinant of matrix 1 into 4 minus 4, that is determinant of A is 0. So this matrix A is singular. Now non-singular matrix. A square matrix is said to be non-singular if determinant of A is non-zero. So see the example. The determinant of this matrix is 2 into 4, 8 minus 6, that is 2, and which is non-zero number. So therefore it is non-singular. When we see details operation on matrices, we see the properties or how to calculate determinant of matrix.